Alright, so now we are at the last episode of this LLM from scratch series, and in this one what we will do is we will just pre-train the LLM with this tiny Shakespeare data. So we have already done all the hard yards. We have talked about the PyTorch essentials, then we talked about how we can do the tokenization and how can we prepare the batches of data which are like input and output pairs. Then we also in the last video in this series we talked about how we can build the decoder based LLM architecture, and in the end also we have shown that we are able to generate text which may not be meaningful at that time, but after doing the LLM pre-training in this video we are hoping that we will do some sort of text generations which are meaningful, right? So if you remember at the beginning of this series I mentioned that the idea of this series is not to build a fully optimized highly performance oriented LLM. So this is just to show you what are the different steps, how you can build the architecture, how you can prepare the data, and then finally how you can prepare the model and then do the pre-training of using that model, right? So with that, let's get started. So first of all, we will repeat the same steps, we will get the data, then we will create a variable which is related to device, and then we will use this get batches function. So here the this function now I have made much more simpler. So it will just take the input and then it will produce the corresponding y and x, right? And I am loading the data outside of this class. So you can see at first I am loading the data, then I'm creating the tokenizer, then I'm just checking the total length of tokens in the data set, and then what I'm doing here is I'm creating the training set and the validation set. So I'm using the 90% of the tokens in the training tokens and 10% of the token is a validation token. So this uh, I have just done this to track the training loss and the validation loss and whether there is a overfitting that is going on while training this LLM or not, right? So then we can see the raw text like first 1,000 tokens, and we can see there is a pattern which is following in this text. So there are new line characters or new paragraphs which are being there after every conversation. So that at least we will expect that that format will be learned by the LLM and that will be captured whenever it will start generating the data after doing the pre-training, right? So once that is done, then I am setting the final params, right? So this is I have done a lot of iterations and found out like these are the optimal params which we can set, keeping in mind the free version Google Colab architecture or the memory consumption that we can go till what point. So if we, for an example, like if we go more heads than this or more layer than this, then it should throw you a memory error, right? So that's why we have limited the number of layer and the number of heads and also the embedding size in that manner. Similarly, we will limit the batch size to 32 and the block size equals to 64, right? So maybe you can try out other configurations like increasing the batch size, decreasing the number of layers, and then you can let me know in the comment how. So then we will initialize the LLM. So these are the things which we have already talked about. At first we create the mask head, then the multi-head attention class, then the feed forward class, and then we will create a single block of decoder block, and then finally we will plug in everything and create this LLM class. LLM class will also be having the generate function which will take the input tokens and based on that it can generate the output tokens, right? So once that is done, then we will initialize the LLM and also initialize the tokenizer, and after that we can start putting some text and see how the output is generating, right? So now at this point of time you can see that the formatting which I have talked about using the raw text, that has also not been captured because we are yet to train the model, right? So when we train the model, at least we will expect that format will be captured when generating the output, right? So then we are setting the learning rate. So once that is done, then we will check like what are the number of total parameters which we have. So we can see there are around 56 million parameters in this LLM. So we will train a LLM with a 56 million parameters, right? So then what we will do is we will initialize the optimizer. So we will use the NMW where we will pass the LLM parameters and also mention the what is the learning rate that we will use, right? So once that is done, we will get a training batch. So using that training batch, we will just do all the steps of training LLM using PyTorch. Like at first we will get the corresponding X and Y, then we will pass the X and Y through the model and we will get the logits along with the loss. So once we get that, we will use this optimizer dot zero grad, which will clear out the gradient accumulations that happened at the previous step. So then what we will do is we will do loss dot backward, which will calculate the derivatives of the loss with respect to the parameters, and then we will do the optimizer dot step, which will actually do one step of weight optimization, right? So once that is done, we will also print the loss, so we can see like we are able to train the LLM and there is no such error. So once that is being tested for 10 epochs, and then what we will do is we will also bring in the validation data set and we will set the max iter as 1000. So we will do this optimization of the weight 1000 times using the batches of the training data, and we will also plug in the validation data set to check what is the loss on the validation data, right? So you can see I have created this val underscore gb, which is nothing but get batch. So using that, we will get the batches of the validation data set, which is not part of the training data set, and we will see how the model is performing on the unseen data set, right? So then we are looping through the max iters, and then at first we are setting the LLM to training mode. Then what we will do is we will get the batches of training data set, which is like X train and Y train, and then we will do the optimizer dot zero grad, and then we will pass the data set to the LLM and we will get the corresponding logits and also the training loss, right? And then we will do the back propagation using training loss dot backward, and then we will do the weight optimization using optimizer dot step, right? And for every 50th iteration, we will check what is the validation dataset loss, right? We are also deactivating the dropouts. So because dropouts are not required when you are evaluating the model or you are making inferences with the model, right? So this lm.eval will deactivates the dropout. Okay, so then what we will do is using this val gb dot get batches, we will get the corresponding xval and yval, then we will pass it through the model to get the corresponding logits and also the validation loss, right? And we will track the validation loss along with the training loss, and we can see like once we have trained the model for 1000 epochs, more or less the training loss and the validation loss are very close to each other, which gives an indication that there is no such overfitting that is going on, and that is kind of a good indication. But yeah, this is not optimized model. You can do several other tricks. You can get better data, larger volume of data. You can use more scale up version of this model to train a better LLM. But this is again just to show you how the whole process works, right? So then we can create a prompt which is like hello can you see me, which I have also talked about in the last video, and then we can like generate the text, and now you can see like we are getting better than what we have generated in the last video without training the LLM, and we can see the pattern which was there in the raw text, like the new line characters or the new paragraphs which get started in that tiny Shakespeare data that has been memorized by the LLM, and based on that this pattern has been matched to generate this type of text, right? And also we can see that if we give a sentence or a paragraph which is part of the training data set, and we are getting much more meaningful output which has been shown here, right? Hope you like this whole series and how we implemented the LLM from scratch. That kind of given you the idea how the basic building blocks are working and how this whole training process looks like, right? The timing, this is all I have for you currently. So let me know your views on this series as a comment, and thank you. See you in the next video.